We're bringing ReefTalk back.
Yeah. Can you hear me?
Yeah, we're ready. We're live.
Okay, great. So I'm going to tell a story tonight. It's a little bit unconventional. This is a story about a couple of corals, at least, maybe a lot of corals. There are no villains. There are no heroes in this story. And the ending of the story is up to us. So I'm going to share a little bit about what I know from my journeys. And the reason I'm doing this is because it's important for us to have a shared understanding. The reason that we take care of something is because we love it. And until we understand it, we can't love it. Anybody ever had a significant other who didn't understand them before? It leads to problems, right? So I love this quote from Baba Dayom, and this was given to the International Union for the Conservation of Nature in 1968, if you can believe that. So we've been at this a long time, and there's a long road ahead, but we're up for the challenge. For those who need to take a phone call or leave early, this is all you'll learn tonight. And if you already know this, then you're good. There you go. Yeah, you grab your phones and get them out. We'll talk a little bit about what a coral animal is. We need to be able to understand that. What is happening with the corals and the work that's involved with changing things. And then I originally was thinking, we can do this work to give us a little bit of an oomph and a little hope moving out of here. But actually, it's not really optional. So those of us who have the privilege of living here in Hawaii, surrounded by coral reefs, don't really have the luxury of saying, well, maybe we'll think about that another time. We must do this work, and I'll share a little bit about why that's the case. So who am I? I grew up next to a forest in Alabama and learned a lot about trees and plants as a kid, mostly which things would sting and which ones you could eat without getting sick. And I moved to Hawaii 23 years ago. The reason that I moved out here was to study coral reefs in Hilo. The reason I wanted to study coral reefs in Hilo was because I had been to the Florida Keys and had my mind blown by John Pennekamp State Park. There were lobsters out in the daytime. There were barracudas. There were sharks. The coral was thriving, just vibrant coral reefs. And I got really excited and thought, wow, I need to do something about that. So I changed schools, changed majors, kind of dropped out of my university there and came over to Hilo. And I've been here ever since. I've had the good fortune to work with the Division of Aquatic Resources on the West Hawaii Aquarium project since 2001. I had the very good fortune to work with the Nature Conservancy for 15 years. So beginning in 2008, started intensively diving along this coastline and counting everything that we could count in the nearshore waters. And for the last 5 years, I've worked for the Palmyra program. Palmyra Atoll, as you'll see in a few minutes, is a small atoll. It's a very small island. It's only about 600 acres of exposed land with a coral reef that is half the size of the reef on this island. Huge coral reef, a lot of life there. This is actually an image from Palmyra, a small seabird chick. Anybody know the species of this seabird? Any guesses?
Red-footed booby?
Yes. Yeah. Is that you, Doug? All right. Red-footed booby. It's participatory.
All right. Omiyagi.
I still have a few stickers from the Palmyra program to give away. So since June, I've been with Hui Aloha Kiholo. It's a local nonprofit, and I'll share a little bit more about that too. But really, the journey has always been to help the coral reefs survive, save the reefs, I guess. It's been ups and downs. It's been quite a roller coaster. So who is Hui Aloha Kiholo? We are a 501c3 nonprofit organization that celebrated our 16th birthday last month. So sweet 16. And we work in the Kiholo State Park area, which is actually a pretty large area extending from Kalaimano in this photo, a couple miles up the coast from here to Anaiho Malu Bay with this mission. So everything we do is really focused around accomplishing our mission to protect, perpetuate, and enhance cultural and natural landscape of Kiholo Bay. And So we look at things from different lenses, from the cultural lens, from the scientific lens, and of course, science is a culture and culture is a science. And we really try to understand everything that's happening and help folks do the right thing and take care of the place like we do. Our staff of 6 work really hard. I won't introduce all of them tonight, but some of our staff have multi-generational ties, maybe 400 years of lineal connection to the places where they're working today. Some of our staff, like me, are new to the area, but all of us really share that same mission and work really hard to do that work. So I promised a story called A Tale of at least 2 Corals. I don't know why I wanted to name it this, but it was good in the end. How many folks have never heard of A Tale of 2 Cities?
Say it again.
A Tale of 2 Cities? Have you never heard of it? Or you have heard of it?
Oh, God.
Okay, it's okay. I'll tell you I've heard of it. So the idea here is to look at corals through different lenses, through our observational lens, through our scientific lens, through our cultural lens, and to look across time, even up to and including millions of years ago, and to look across space. So what does coral look like here compared to down the coast, compared to Palmyra Atoll? So we're gonna do all of those things. And here's our quote. Along the top, we have some healthy corals from Hawaii, and along the bottom, we have some healthy corals from Palmyra Atoll. And the colors are much the same. The characters are very similar between these 2 places. And the potential is great for both of them. But if you haven't read the novel, it talks about London and Paris, and at the same time, all of these things are true. Has anybody ever heard of a Hawaiian creation check called the Kumu Lipo before? So in the Kumu Lipo, there is this concept of duality. Duality is two things. There's typically a species on land that's a protector for a species in the ocean, and those 2 coexist as a single entity, a single connection between the 2. And so this concept of duality is throughout the Hawaiian cosmology, super interesting. We can go really deep on that another time, but I thought it would fit well with Dickens in a Dickensian way. What is this image showing? Anybody know?
Pacific Ocean.
Yes, both Earth and the Pacific Ocean. And Donna, that's the most precise answer, so there we go. How cool is that? When you look at Earth from space, how big this ocean is. I love this view. A third of the planet is the Pacific Ocean. Of course, really, there's just one ocean. There's no second ocean, but the Pacific is the largest piece of ocean, and so we should get a lot more attention than the rest of the world, I think. Yeah, and you see Hawaii, and we'll make it easier to see Hawaii in a second. So in the heart of the Pacific Ocean is this place I mentioned a couple of times called Palmyra Atoll. It's an uninhabited island. The folks who live there year-round are the Nature Conservancy and Fish and Wildlife Service staff who keep everything running, take care of the place. There are seasons where researchers come down and do a lot of science. There are seasons where nonprofit supporters come down and have a lot of fun and go diving. But for the most part, it's a quiet place that's surrounded by coral. And we can both compare and contrast that to where we live here in Hawaii. There are places on this island that are very quiet with very few people. And then, of course, there are places that are quite popular. So we have a larger span than Palmyra does. But the point I want to make with the next couple of slides is that although these places are 1,000 miles apart, they're actually strongly connected. A lot of us who grew up on land and terrestrial cultures think of the ocean as this great expanse that we have to cross, as this great divider. But for the peoples of the Pacific, what better way to get around than the ocean itself? It's a great connector. And so this is an image that's been modified from some work that was done in the 1960s looking at the Polynesian migration from Hawaiʻi. And Hawaii is actually kind of down here more, but I had to curve it. And the original Hawaii in Tahiti. It's the folks made their way here, and in every other direction it was depicted by the tentacles of the octopus. And we'll look at the expanse of that Polynesian nation in just a moment. but it does connect Hawaii and Palmyra in an interesting way. So does anyone know what this location is in the background here?
Kaaloa.
Yep, Ka'avaloa. So distinct even today when you come into this bay, Ka'avaloa, in Kealakekua Bay here on this island. And one thing, you know, Captain Cook has a mixed reputation in Hawaii and should. You know, the sailors might appreciate the fact that he worked his way up from an able seaman in the crew quarters to be a captain. That was extremely unusual. In fact, I think unheard of at the time to not be born into a noble family and to become a captain. And indigenous peoples will rightly note that he brought disease, he brought all kinds of challenges to the places that he visited. But like all of us, he's got a lot of aspects. There's a lot of aspects to Captain Cook. But one quote that really stuck out to me was his acknowledgement. This is probably the best European navigator in generations. And he acknowledged how impressive it was that everywhere he went in the Pacific, there are these folks that speak similar languages, that have similar crafts to get around, that have similar building structures. And he acknowledged this great nation, he called it, the nation of Polynesia, of which Hawaii is a part. But don't take my word for it. This is some work from Pila Wilson over at the University of Hawaii Hilo looking at languages of the Pacific. And so here, just to orient us, are the Hawaiian Islands. There's Palmyra right there. He comes across to the Marshalls, Tuvalu, Fiji, Vanuatu, all the way, and then we would have, of course, New Zealand, Aotearoa, all of those islands in here, and looks at the different language groups to try and understand where did people land, where did they go, how long were they there. What his findings seem to indicate is that the Polynesians of this more easterly area have a very similar language and therefore a very strong cultural connection. And he postulates, based on language, that the Line Islands, the Southern Line Islands and the Northern Line Islands, were the jumping off ground for the Hawaiians that came here to Hawaii. There are many theories out there. This is one, but this is actually the most recent theory. So there's a lot of interesting things to think about here. In a little while, we'll talk about corals and what they are, but I'll give you a spoiler alert. Corals are colonies, and this map has a lot of colonies in it. So we have colonies of the German, before Germany, the German nation, of Spain, of England, of France, of the United States. These scattered islands really were peopled, but they were also colonized by foreign powers. And the legacy of that continues today. So if you want to find out more, check out Pila Wilson's 2021 paper about the origins of the Hawaiian people when they got here, because they too are colonizing. The Polynesian people were colonizing these places. Maybe they were the first to land in these places. Maybe they followed other groups. Certainly the art of navigation that was retaught in Hawaii came from Satawal in Micronesia. And so the Micronesians, amazing navigators, traveling to all of these islands as well. They were crossing in space and time. But as Polynesians moved through the world, they identified this interesting observation. Hey, puko kani aina. So pukoa being the coral, kani aina to strengthen into the land. This translates to the coral reef strengthens into the land. But what does that really mean? Today, there's poetic references to the fact that we grow and we learn. But this is a literal observation of the peoples of Polynesia as they traveled from large volcanic islands to smaller islands and eventually to coral atolls. The coral reef itself will be the ultimate land of these islands. And so the coral reef strengthens into the land, acknowledges that connection, a deep connection between corals and islands. And since they were the first to explore these areas, they identified this, a puko kani aina. And the next person to suggest that something similar was happening was in 1842. Anybody want to guess who came out with some interesting theories in 1842?
Darwin.
Yep. Yeah. So Charles Darwin or the beagle. This was also a controversial theory. It's held up pretty well. There have been some nuances to it, but essentially it holds water. What Darwin was looking at was these progressions of islands as he traveled through on the Beagle, and he noticed that there were large volcanoes and that there were also atolls, and it seemed to be a pattern. The larger islands got smaller and smaller, became coral atolls. So what he postulated is happening is that the coral reef is growing up the edge of these islands, and then eventually growing on top of the island as it subsides. And so when the coral eventually grows on top of the island, it's all coral up here at the top, and this is an atoll with the exposed land and the lagoon area here. So that turns out not to be 100% correct, but pretty correct for 1842. If we were to drill down through the islands of Papahanaumokuakea or Palmyra or any of the other atolls in the Pacific, eventually we would hit volcanic rock underneath, maybe hundreds of meters underneath. So what does that mean? The coral is growing hundreds of meters up from the island itself over eons. So it's a pretty amazing observation, and just something to think about and to reflect on. So thinking about this big ocean and these islands in the ocean is pretty awesome. It's pretty amazing to imagine all of the possibilities out there, what we know and what we don't yet know. And one thing that we know here in Hawaii is that speciation has occurred. So this is a kind of a famous image of the finches that evolved from a finch that looked more or less like this into a great diversity of finches here in Hawaii. It's not a bad time to mention that a lot of our forest birds are in trouble, and there are people working really hard to take care of them. They're exploring some techniques that have a lot of promise and potential right now to take care of forest birds. And this is something that we should all follow very, very closely, because just like the corals, our responsibility to these birds is real as well. We share their home. But as impressive as those birds are, 1 in 5 of our fish are found nowhere else on the planet as well. And 1 in 4 almost of our marine invertebrates are what we call endemic, found only here in Hawaii. Here are a few of the highlights. I picked the most handsome and attractive ones to show, of course. Beautiful fish that if you were to snorkel on the Great Barrier Reef in Indonesia and East Timor, where the highest diversity in the world is, you won't see these species. Species are only in Hawaii. Similarly, let's talk about the best of times. I love these photos of healthy coral. This is an endemic species called Coralʻs evermani, and it also used to be called Coralʻs lutea. Some people know it as that. In certain forms, it can be kind of purplish. Other times, it'll be kind of brownish and yellowish. If you look really closely, you can see it's a bit fuzzy, but a really cool endemic species of coral. Why am I showing this? Because in a minute, we're going to look at this coral under different ocean conditions and just know that it's an endemic species, fairly slow growing. So that leads me to the question of what is coral? And Cameron is going to help us out here by just passing out some coral samples. I think these coral samples were legally obtained. They were given to me by a former Sea Grant extension agent. I won't mention her name just so she doesn't get in trouble. But yeah, we do use them for groups. So if you want to take it, there's a coral that's going to be making its way around. You can take that in the magnifying glass and peek at that coral a little bit and see what you see. And while you do that, we're going to talk about first where coral came from and then what coral is. Now we've been talking about thousands of years Polynesian migration across the Pacific. Well, let's go a few million years back, maybe 400 or 500 million years back, and think about what the Earth was like back then. One thing to look at is the amount of carbon in the atmosphere relative to the present day. there was a period on Earth where the atmosphere was full of carbon. The land didn't really have many organisms that were taking up that carbon, nor did the ocean. And so it spiked, and it spiked high enough that it's a dramatic increase in what we're experiencing today. And notably, the world in that time had 0 humans. No humans were living in those days. But not too long after that spike, we started to see an animal that, well, I'm going to give myself away, but we started to see something come into the world, and that was the coral species. Distant relatives of the corals we have today. Today's corals are evolved from these, but 450-ish million years ago is when corals started to arrive on the scene in any kind of significant numbers. We know sharks are ancient species. From somewhere from 250 to 400 million years ago is when sharks started popping up. That's a huge range, by the way, but that's what we know. And then dinosaurs, 250 million years ago or so. And then way over here in the corner is us. We're pretty new. But what this tells me is that when everything else is going in their favor, corals are pretty adapted to different climates and different conditions. And so that when everything else is going in their favor is a huge key point. But let's get to know the coral a little bit. When you look at the coral that's passing around, you're going to see kind of a raised ridge with a hole here because there's no live animal on it anymore. So what you're seeing is the ridges on there are these are called calyces. You don't have to remember any of these words, it doesn't matter, but just suffice it to say that the coral lives in a little cup and it has the ability to get energy 2 ways. Anybody know what those ways are?
Zooxanthellae and whatever's floating around.
Yep. So from sunlight via zooxanthellae, and from actively feeding with the polyps. Some people think coral kind of looks like a jellyfish or an anemone or something like that. They're cousins. They're pretty close relatives, and those polyps are capable of eating food. When they eat it, it goes down here into the stomach, and anybody know where it comes out?
Same way it went in.
Right back out the mouth. So we're glad that we've evolved beyond that. But yeah, so coral doesn't have a through gut, has a very simple gut. And another thing that it does is it forms colonies. So initially, one coral polyp, this is a coral polyp, will clone itself and become 2, become 4, become 8. These colonies of coral are all connected through a very thin layer of tissue. And these layers of tissue are the small connections between the polyps. Not true for 100% of coral species, but it is true for most. They have the ability to let things in and out. And so how many people have heard of ocean acidification before? It's a problem, right? It dissolves the shells of marine organisms. As the oceans become more acidic, animals that live in the ocean have a hard time. And coral is no exception. But some interesting work on corals showed that they can survive down to a pH of about 7.4, which you don't need to know anything other than that's super low. That's really low. But the problem is they don't grow skeletons anymore. Their skeletons can't grow below a pH of about 8.2. So we're not going to get reefs that are like reefs of today below a certain pH, but they are able to protect themselves. They're also able to share energy, share nutrients, share the things that keep them alive using these tissue layers in the animal of the coral.
The corals that rely on zooxanthellae, how long can they live without that algae as a filter feeder?
It really depends on how big the stress is that caused them to lose it, and it depends on their fitness. And we'll actually share a little bit about coral fitness.
And can the zooxanthellae come back at some point?
It can, yeah. Yeah, that's the hopeful thing. And by understanding coral fitness, we can understand actually maybe some things that we could be thinking about when corals do bleach. And we'll actually get into mechanisms of bleaching in a second. But before we do, I have maybe a pop quiz for everyone. How many people Now that you know how coral kind of works, how many people think that coral is an animal? All right, oh, awesome. Okay, good. How many people think that coral is a plant? Anyone? Some folks on the fence. How many people think that coral is a rock? Well, good news. This is the best kind of quiz. You're all kind of correct. You're passing around the coral calcium carbonate skeleton right now, and that looks like a rock to me. But that's not the live coral. So let's talk about the way that coral is all of those things. If you guessed plant, and there are only a couple brave souls who went there, but thank you for doing that. There is a symbiont that lives inside of the animal of the coral. It's called symbiodinium, or zooxanthellae is probably the term that most people who want to say big words know. Can we all say zooxanthellae?
Zooxanthellae.
It's fun to say.
Lovely word.
Yeah.
And spell.
Yeah.
That and caudal peduncle.
And so notice a couple things here. The tissue of the coral is transparent in this slide, this cross section. The zooxanthellae, symbiodinium cells are colored. And so the pigmentation of the coral really comes from these plant cells that live inside of it. Okay, rock was also a little controversial. Didn't get a lot of people guessing rock, but as the coral grows, it grows in layers, and it secretes layers of calcium carbonate, layer upon layer upon layer upon layer. And atolls that are 60 million years old, like Palmyra, can have several hundred meters of corals that have grown at that tiny, tiny rate from year to year. 1 centimeter a year is fast for some corals. Okay, and then, oops, I skipped that it's an animal, but we know it's an animal. It looked like an animal. So coral is also an animal. And so some people will compare coral to things like trees, and that's fine. You could do that. But a tree is not an animal. A coral is actually probably, I mean, I'm biased, the most interesting thing in the world, because it's an animal and it's a plant living inside of it, and it's a rock and it makes islands. But I moved to Hawaii to study coral, so don't take my word for it. And this is what it can do. So we think about the relentless power of the Pacific Ocean, ability of these huge waves not only to break things, but to suck us out to sea and to drown us and to destroy houses. But when they hit coral reefs, they can be absorbed. The energy from these huge waves can be absorbed by these fragile, fragile animals working together and growing together. Truly remarkable when we see that happen, when we see the waves break on the reef. So how does the coral do that? How can a coral stand up to the force of the ocean and not break, not die? How does that happen? How can it recover from stress? Well, I'm going to share some theories about that. Firstly, let me just share the coral reef kind of exists in this zone right by the island. And so we can see a lot of fish living on the coral. Anybody want to guess what this bird is doing?
Fishing.
It has been fishing. And so the bird fishes, it eats, it digests, and then what does it do? Yep. Yeah, so this is a little poop syndrome coming down here. I don't know. It's kind of funny. Okay, keep that in mind. All right, so here's the island. Look at this predator-free island for a minute. It's got land crabs. We know Hawaii had land crabs when the Polynesians arrived. They're not here anymore. We know Hawaii had flightless birds. In fact, we know that Hawaii had all kinds of birds. Anybody want to guess why we don't have as many seabirds today?
Predation.
All right, you got it. You got all of them.
Humans.
Mosquitoes.
And humans, yeah.
Yeah, we ate them.
Yeah, mongoose, cats, rats, humans. All of those are at play. You know, rats and mongoose and cats will eat the baby birds. They'll eat the eggs. They'll eat injured birds. And humans, we change the vegetation. We move things around. These heliotrope trees that we have on the coast here, if you were to go to Palmyra and see a heliotrope tree, it's like an apartment building. It's loaded with birds. There's like not room for another bird. But here in Hawaii, the red-footed boobies and the brown boobies, which we also have, sit on the fish farm buoys. They sit on the buoys at Kauai High. The only place that you'll see them is staring wistfully at the land that their ancestors knew. And then let's not forget what's beyond the reef, the ocean, the deep waters where the predators live. And we can think about these systems as being separated. I did. When I was in school, I thought, let's learn about the coral reef fish and the corals and not think about the rest of it too much. And in fact, I was able to do that for about 10 years of my career and just keep my head in the water. But we know today that these corals really depend on what's coming off of the land. What's coming off the land is super important. And we're learning that not only that, but they depend on what's coming in from the deep sea. And so I'm going to explain a cycle that was a bit mind-blowing to me, maybe old news to some of you. But when I started working at Palmyra, I had to ask for this to be repeated several times. So if you have questions, let me know, because this is crazy. These big fish that live out in the deep ocean waters are eating small fish. And the small fish live anywhere from the surface of the ocean down to several hundred feet, maybe 1,000 feet at the most. But the big fish, when they're hungry, need some kind of barrier to push them against. There's no barriers in the middle of the ocean, so what do they use? They use the air. The sky is their barrier. They make these schools of fish come up from the deep water right up to the surface of the ocean, and that's like a wall that a fish can't really get beyond. A flying fish can do it for a little while. Most fish can't even do it that long. And they feed. So they're called bait balls to those who love to fish. But yeah, there's these just swirling vortices of tiny bait fish and predator fish eating on them. And what that does is it makes them available to seabirds. Seabirds can't dive down hundreds of feet, but they can skim the surface of the water. They can dive down tens of feet, some of them. So they catch these fish at the surface that are driven up by your healthy fish populations, sharks and yellowfin tuna in this case. Anybody know what yellowfin tuna's claim to fame is? Mahi poke, sashimi. By volume, this is a $4 to $8 billion per year fishery, the yellowfin tuna fishery. We'll go into that today, but suffice it to say, there's not a lot of places in the world where yellowfin tuna are not actively pursued and under threat. But Palmyra is one such. And do they move beyond those boundaries? Of course they do. We're trying to understand that right now through some research that I can talk more about later. But they drive this fish up to the surface, and then the birds come back with the fish in the beak, and they feed their babies, and they go to the bathroom, and they make guano. And what's happening with that guano, it's very rich in bioavailable nitrogen and phosphorus. I say bioavailable because you can buy nitrogen, and you can get phosphorus in your detergents, but they're not bioavailable. If you could imagine having those kinds of chemicals, plants love them, but we're not really trying to feed plants here. What are we trying to feed? We're trying to feed coral reefs. So look at these plankton that are growing from the guano that has washed out with bioavailable nitrogen and phosphorus into the reef. Not only that, the seabirds creating the food for the plankton, that is the food for the coral, but sharks as well. Sharks are cycling nutrients from deep water to shallow waters through their diurnal feeding activity. In Hawaii, spinner dolphins are feeding offshore. They're bringing bioavailable nutrients back to the reef and back to the corals. So we might want to think about things a little differently. We don't think of this very often. Sharks are feeding corals, and I'll explain why that's important in a minute. But coral protectors. So these seabirds and these sharks are vital components of a healthy coral reef. And they also make something that humans really like. Does anybody know what the Guano Act, or Guano Islands Act of 1856 said?
If you find it, you can have it.
Take it
You
all.
can take it.
If
No
you're
regulation.
a citizen of the United States and you find an island and no one happens to be on that island, but there's guano on that island, you can claim it for the United States. And so I was used to claim a lot of islands, and you can guess which government decided the Guano Islands Act would be passed, but there's a lot of islands in the Pacific that were claimed under this 1856 Act throughout the Pacific, hundreds of islands. Today it's dwindled. Most of them have been given back to the nation states that are nearby. But this is kind of neat to think about the competition for guano. So it's not just corals that want guano. Before we could make nitrogen fertilizer easily, our humans wanted it to grow food. And that's how we're able to grow a lot of food. So it's really benefited our species. Because we're in the 1856 area, I just want to point out this 1859 lava flow. Two reasons. One, it's right next to Keolo. It created Laiho, which we're going to see in a minute, and we'll see the corals on that point. But also, this is an article from Harper's Bazaar in April 16th of 1859. I don't know if you can see it, but this is a baby being thrown from a coconut tree to awaiting people in a canoe. This is a flow from Mauna Loa that reached the ocean in about 6 days from an altitude of 11,000 feet, covered a village called Waiʻi. And the village today is underneath lava, and the reporter took some artistic license with the folks who were getting out of the way. I mean, it's pretty fast, 6 days. But I don't think it's fast enough to trap you in a tree. So they took some artistic license, but this was a pretty cool event. Why am I talking about it? Because can you imagine anything that would be worse for a reef than being covered with a cap of molten rock?
Right.
And it's not just what's at the top, right? There's lava that's broken off and gone down. It's flash boiled the water to steam. It's killed everything. There's nothing on that reef anymore. And yet within 20 years, the reefs are looking pretty good. This flow is from 1859, and you can just see all the live coral that's out here along the edge of it. So it's perfect substrate. This island has just got a perfect substrate for reefs in a lot of places. And so that's what we would call an acute stress, lava being the acute stress. Anybody feeling stressed? Because we're going to talk about stress for a minute. So if it's a trigger, we'll step outside. So acute stressors are things like big storms, hurricanes. This is some work. Sorry, let me get the citation here. 2021 work from actually the Caribbean, but it holds true here. These big events, they happen, they move through, and they're done. So that's an acute stressor. Contrast that to chronic stressors. Chronic stressors is every day I wake up and my neighbor's dog is barking 100% of the time. It's coastal development, it's sewage water, it's coral diseases that stick around. They don't just move through in a flash and move on. It's fishing pressure, and we can add to this list with all kinds of things, anchors and trampling and sunscreen and fertilizer, you name it. So what happens is these chronic stressors and acute stressors interact. And they interact around something called a tipping point. You get too many stressors, it tips the balance, and the reef goes from live coral, healthy coral, to a different phase, typically dominated by seaweed, by algae. You've watched corals that get eaten, and then they get turned into algae, and then they dissolve by urchins, and the cycle continues. So just important to keep in mind the difference between chronic stressors and acute stressors. And I wonder if anybody can think of any coral stressors that we have on this island that I haven't mentioned. Anything top of mind for everyone?
Silt.
The people, how so?
Walking on the coral, damaging the coral.
Trampling the coral, yeah, physically breaking the coral from walking on it.
Silt runoff.
Silt runoff. So do you want to say more about that, or you want me to?
Loss of forest, lots of rain,
Yep.
dirt goes
Coastal
into the
development.
ocean.
Yeah, so we lose the roots holding down the soil, and we get a big flood, and it runs off into the ocean. There's an atmospheric thing that happens with hurricanes and fires and rains. So typically before a hurricane, the moisture in the air will be reduced. It's getting sucked into the storm. Fires become more likely. So then the fire burns, and then you get the moisture coming back after the hurricane passes through. You get rain. And we see this pattern in Kohala a lot. We'll get a fire that moves through, and then we'll get rain afterward. So that's another stressor. Anything else?
So once the coral dies, it becomes rubble, and during high surf, that rubble becomes an abrasive slurry that just can kill more coral.
Yeah, it's like a bulldozer moving
exactly.
through areas. Yeah, absolutely. Some things that I don't know much about, but that we might want to think about include sound. If we stick our head in the water on a healthy coral reef, we can hear all the snapping shrimp, we can hear all the life and the action. When a reef is dead, you don't really hear that. in between those two things, how important sound is to help corals to settle is something that a new field of study that's showing some really promising results. If you can make a reef sound healthy, corals are more likely to settle on it. So noise pollution. There's a kupuna from Kailua Kona who used to talk about boats, propellers. When coral larvae come to the surface, they come to the surface right at the surface. Some fish larvae do as well. So if there is a zone through which boats are driving all the time, who knows what happens? So there is no end to the things that we could think about that could potentially and likely are negatively impacting reefs. I'm not saying boats are the reason that corals are not recruiting in high levels in West Hawaii, but there are folks who have proposed that, and it'd be a really cool thing for somebody to study. So I'm going to talk about a specific response of corals to a stress that, I don't know if we mentioned this one either, but it was in the first slide. This is hot water. So if we look at this, this is a NOAA product. This is yesterday's map. So I don't have today's, but this shows where the water in the Pacific and the Indian Ocean and the Atlantic is elevated above what we would expect for that area at this time of year. If you don't know anything else, just know that red is hot, and dark red and brown is really hot, and purple is super hot. So this is a measurement called a degree heating week. You're asking how long can a coral, what can a coral recover from bleaching? Degree heating weeks is a measurement of essentially 1 degree centigrade over the threshold for 1 week is 1 degree heating week. So you can get 2 degree heating weeks 2 ways. You can get it from it being 2 degrees over for 1 week, or 1 degree over for 2 weeks, and on and on and on. When we had our big event in Hawaii, this is what our map looked like. So right now, we're sitting pretty okay. There are a lot of us who are very worried that we're going to get a big bleaching event this year. And I'll talk about bleaching in a second, but we thankfully didn't. But in 2015, when we had 18 degree heating weeks in Hawaii, this is what our map looked like. So alert level 2 means this is an alert level at which bleaching is likely. We've had consecutive record-breaking temperature years for a long time. We might have an outlier here or there where it's not hotter than ever before, but what seemed to happen in 2015 was this oceanographic blob of hot water kind of got stuck here, didn't move on, and it bathed our reefs in really hot water for a really long time. So that was an acute stressor, and it caused something called bleaching. We know already bleaching is when the coral loses its pigment. Does anybody know why it loses its pigment? Wait, have you heard this before? Okay.
Yeah, let's go with its algae because it can't sustain the algae and then it loses its food source.
Right, so let's go with its algae because it can't sustain the algae. And the specific mechanism for that is the algae actually gets super excited, very energized. There's too much light energy for the algae to process and the cells will rupture. And so when they rupture inside the coral has a response, there's something bad inside of me, it expels everything. And so that's the mechanism behind bleaching. And once it shoots those algae out, then we see the skeleton again of the coral through the animal. And so that's what that bleached coral looks like.
And bleached coral isn't necessarily dead.
Right. Yep. This coral is not dead yet. So
Like
not necessarily dead.
intensive care.
And there's actually a really cool thing that happened here. So this is a photo from Hawaii of that same species, the Prias evermani that we were looking at before. And you can see this sort of weird stuff here. It secreted likely a protective film that covered the coral. As the bleaching continued, eventually that film sloughed off from the corals. So they have some natural defenses against these hot temperatures, but are they enough? Now, when the coral bleaches, you mentioned it can't get energy from the sun anymore. So that mechanism is cut off. That's called autotrophy. You can forget it. As long as the coral is bleached, there's no sunlight that's helping it in any way. But we also know that corals can eat with their polyps. That's called heterotrophy. And during a bleaching event, corals can continue to eat. Prior to a bleaching event, corals can eat. Corals can develop reserves of energy. And so the heterotrophy is not necessarily affected by bleaching. And we know that coral is a 450 million year old animal, has evolved to do both.
Do they become more vulnerable to fouling and attack?
Oh my goodness. I think we must be working together. The question was, did they become more vulnerable to fouling and attack? And I don't know, when I think of vulnerability, I think of Brene Brown. Absolutely they do. Yeah. So vulnerability is not something you necessarily want in your coral reef. And there is an image of our West Hawaii coastline. Just know that red is kind of bad, green is kind of good. And we can look up and down the coastline and see the different vulnerability scores.
Where is that data from on the right?
This is from the Division of Aquatic Resources, NOAA, and the Nature Conservancy's multi-year surveys combined. This is about 10 years of data. And this report was published in...
Does it include airborne surveillance?
Not yet.
Or all ground
so
truth?
that's certainly happening with Dr. Greg Osner and his
Right.
team. Yeah, this is people in the water with masks. And actually that's what that looks like. So you go to places where the reef is not doing too hot, like Pelicane Bay, for instance, and you do some dives there and try and find coral. And then you go to places where the reef is doing a little bit better, and you look at the corals there. And that vulnerability score is made of a series of things that make a reef more susceptible to bleaching, and then not just bleaching, but dying after a bleaching event. For corals that don't recover. Because if the conditions come back to a favorable state, while the coral still has energy reserves, or while it still has food to eat, it'll just reabsorb those zooxanthellae and go on living. So they can survive bleaching events, but there's a threshold that they can't go beyond. So what these divers in the water are looking at in a lot of these data points looks like this. This is a picture of benthic habitat. You can see a little bit of bleach pagoda down here. Most of this is pretty healthy. The white might be washout from the flash. Some Mantipora capitata there. Go back to the lab and you identify points. And from that, you come up with your coral cover percentage and also your coral size class. Those are important. But there's also some interesting things, and you're mentioning the coral zits before. And actually, look away from this if you don't want to change the way you look at the reef. Spoiled that. Don't look at this if you don't want to. But if you want to see beyond, okay, there's a coral. That coral is alive, or that coral is dead. Coral disease is one of the ways to do that. And so these diseases happen on our corals. This is called a growth anomaly. See how the coral is kind of uniform, and then it gets like this tumor thing. That's a growth anomaly. This is ciliate, so this is growing up the coral. This ciliate is actually kind of stinging the coral cell, causing problems for it. We can see algae progressing up this coral here. That's tissue loss syndrome. Anyway, I won't go into all of these, but I want to talk about this one because it's kind of fascinating. Have you ever seen a lobe coral, lobata, that has little dots all over it? This is from a symbiotic process with a coral-eating butterfly fish. It will come to these dots and it will feed on them. And inside of those is a tiny little worm that mates in the gut of the fish and creates offspring. And then the offspring get pooped out and fall into the reef and create little coral zits. So, cool story about connection.
So one in the lower left does that caught predation?
Yep, that's COTS predation. Good. Yeah. So the way you can tell the difference in COTS predation and bleaching, does anybody know? It's really hard actually with this species, so it's not a great example, but if you can see live tissue on the coral, then it's bleaching. If it's been eaten down to the bone, that's crown of thorns sea star predation. That's a coral predator, and it eats the tissue at all when it eats the coral.
Also, just looking a little bit larger, if you only see 6 or 7 of those, it's crown of thorns. If the whole reef is bleached, then it's environmental.
Yes, and there are some stressors that are localized enough that you could see bleaching over an area that's smaller. Certainly not the thermal stress event we experience, but let's say there's an outflow pipe that's pumping hot water out, and that's happened here on our coast. You could see bleaching in a discrete area or something like that. But yeah, for the most part, if you see, especially if you see these kind of in the same area or in a line, usually follow them to find that crown of thorns sea star. Does anybody know whether crown of thorns sea stars are native species or invasive? Cameron, do you know this one?
They make it so that the coral can grow, and they also make it sick.
Awesome.
Their lines are
I can't imagine they were introduced.
Yeah, they're native. So,
They're native,
Yeah.
okay.
It's just the
Yeah.
balance.
and this is a battle that I don't have to fight anymore because I'm not working at Palmyra. But there are folks there who said, sure, they're native, but they're only 45 million years old, and these corals are 450 million years old. So corals don't know what to do with this youngster in the neighborhood. So anyway, there's debate within the scientific community of whether or not to manage them in places with relatively few other stressors.
But
But
they're,
suffice to say, they eat coral.
but they're food for
Triton.
Triton trumpet.
Triton trumpet.
And that's a photo I don't have. Do you have a good photo of Triton's trumpets? Okay.
Yeah, I
I have
do.
to talk to you after.
I have one of the in a cushion store.
All right. Well, get ready to think about things from a bad perspective for a minute. It's going to get better, I promise. So it's the best of times some places, but it's the worst of times in others. This is before that thermal stress event of 2015. You can see the last survey was done just before 2015. I won't say where this is from, but what it shows is preponderance of evidence dating back almost, let's see, that's 40 years of coral gradually declining over time. This is percent live coral cover. Remember that image of the reef we saw, and you could see what was alive and what was not. And this is time down here. So a pretty clear downward trend has been happening in Hawaii for a long time. This is not a surprise for a lot of people, but it's interesting that it's documentable and provable. And it's certainly something that in time, I'm sure we'll have coast-wide aerial imagery that dates back that long. But right now, this is, again, all from in-water surveys. Now, what this is showing is a single year of loss. So the last slide is showing over the course of 40 years, about a 50% reduction. About half the corals died over the course of a 40-year span. This is from 2014, before that bleaching event, to 2016 after the bleaching event. And what it's showing is the loss of coral cover. That's the number in red, is how much coral cover at this site was lost after that event.
Any particular species or all species together?
This is the lumps. These are, this all species aggregated together for this assessment.
Where is that?
The 99.
Tahoe is on the right.
This is up the coast in Kohala, South Kohala.
Oh,
Yeah.
How's that book?
So is that Four
Cool.
Seasons?
Yep, Kohala.
And that previous line graph, was that for the whole state or? particular
That was for a
area?
particular area. It's actually, well, I'll just say it. They're both for Kohala. So
Okay, so
there's
this
some
is
things in here I
Pu'ukoʻa.
probably won't say where they were, but this one, this is Kohala. So 50% over 40 years, 50% plus over 1 year, but that doesn't mean forever, so something to keep in mind. But these stochastic events, these acute stresses from things like bleaching,
The red is the number lost or the number still there?
the red number is the percentage coral cover lost.
Lost.
So let's say that this site had, let's say it had 50% coral cover when it was surveyed in 2014. It had 55% less coral cover when it was surveyed in 2016. That's what these numbers mean. All species aggregated together. Okay, and we're almost through the painful part, but I want to show you what that looks like.
Wow, that's huge.
This is a Parietes Evermont I had. Dr. Paul Joe Keel looked at this slide and said this coral head is at least 300 years old based on its size. So we imagine that slide of Captain Cook coming into Kealakekua Bay. This coral head was here when things were happening that we have no record of. And so this is a survey that was going over this coral head. It was huge. We wanted to document it. It was right in our transect. So we snapped a snapshot of it. And in 2015, this 300-year-old coral head exhibited bleaching, full bleaching essentially, 100% bleaching of that coral and almost all the corals like it in the vicinity. We know that if things are not too bad, the corals can recover from this bleaching event. So we didn't get too worried. We continued to survey. We were out there at the height of the bleaching event, got a lot of data on how much coral bleached. But it was sad to see that within a couple of years, and these are different corals of the same species, but this is basically what happened. We had algae that came in and grew on that coral. And so that means that's no longer a suitable substrate. And actually it was faster than a couple of years. I take that back. This was weeks where the algae started to come in. So bleaching grows that tissue, that sloughing tissue, that doesn't work. And the algae comes in, it can grow pretty quickly over the coral. And so unfortunately, we lost a lot of coral. And for somebody whose job was to kind of take care of the coral, personally, this affected me really deeply. I got depressed, actively depressed during this time period. I thought about, what this meant, and I thought, well, at least we'll probably see what's happening and we'll change our ways. But yeah, I mean, for the most part, we went on about our lives as usual, myself included. There wasn't an adaptive response. And that's something Hawaii really needs, is adaptive management. It doesn't make sense to manage the ocean like it's going to be the same forever. And it's a hard battle to say, okay, we have rules, but let's change the rules if we have a huge event like this. But it's necessary.
It's a perfect situation of out of sight, out of mind.
Right.
Most people have no clue what's going on below the surface.
Right. Yeah. I like that. Most people have no clue what's going on below the surface. So that brings me actually to a pretty cool observation from a kumu la'au lapa'au, a Hawaiian healer, a Hawaiian kumuhula, who says that when you look at medicine, you don't heal by seeing the sickness, you heal by seeing the wellness. So there's a lot of stress for the reefs. There's a lot of doom and gloom. There's a lot of problems. They're real problems. But if we focus on those, we lose a huge opportunity to learn. So we started looking into a science called resilience. Resilience is not resistance. It doesn't mean that coral is not affected by these stressors. What it means is that it can recover from the stressors after they occur. So in a coral reef context, resilience is that ability to recover. And the same data that show vulnerability can actually show resilience. So I'm going to show a time series. This is some folks at Scripps at a reef in Palmyra. The time series starts way back in 2013 and it extends to 2017. In 2015, 90% of the corals at Palmyra bleached. So keep that in mind as you look at this video that's going to play.
All species, Chad.
All species. Is it going to play?
Trigger.
Maybe it's not going to play.
Oh.
Darn. Let me see.
Had that happen before.
I'll see if I can play it at the end. But basically what happens is you see coral bleach, bright white, and then start to recover and then fully recover for most species within 2 years. And what that looks like underwater would have been this video, but sorry about that. But what it looks like to a scientist is this. And this is super exciting. The reason this is exciting, we already saw a graph with percent cover of coral where it was going like this, right? That happened. This graph is percent cover of crustose coralline algae, hard corals. So hard corals are what we think of mostly as corals. Crustose coralline algae is what the corals land on and start to grow from. It's awesome to have crustose coralline algae. Then you have the next generation of the reef. So just keep that pink line and the kind of greenish line in mind as you look at these and see there's very little trend. One of the sites has maybe a downward trend, although it's not really statistically significant. For the most part, these sites in 2010 are the same as these sites in 2018 when these data were collected.
What's the difference between FR and RT?
Okay, for reef, and so these are deeper sites, and reef terrace. RT is the shallower sites. That's a good question. And so we think maybe thermal buffering is a factor in some of these instances, but no difference in those reefs that are bathed in sunlight all the time. They can still be very resilient to what's happening. Why? Why did we lose so much coral in Hawaii? It's making a slow recovery, but why did so much die, but not in Palmyra? So that's a really interesting question that we're going to explore a little bit, because these are corals that have bleached, died, gotten covered with crustose coralline algae. The whole system is intact and it's full. And the reason for that is because very few stressors from land that are coming out onto the reef. There are no rats on the island. Rat-free islands have more coral resilience because of that seabird pathway we talked about. Sharks and tunas are fully protected. So you've got the whole ecosystem that's there. And at least for now, that is strong enough to withstand the thermal stress that climate change is creating. Will that last forever? Almost certainly not. But that's why I wanted to call this a tale of two coral reefs, because there are places in the world that are adapting, that are tackling these stressors. There are places that are not. One of the things that really excited me making the switch from Palmyra to Kiholo is because this reef is amazing, and would that we could all go see it someday. It's a precious place on the planet Earth. It's feeding no one. It's creating livelihoods for no one. It's protecting no one's house. It's not creating the things that the reef in Hawaii creates. This is the place where protecting the reef is as important, more important than anywhere else in the world. So let's talk about resilience. And this is just an image of that 1859 lava flow. Came down from Mauna Loa, went around Pu'uwa'awa'a, Pu'uwanahulu, hit the coast, created a mile of new land. So this would have been the bay before, called Laiho, massive event. And yet if we look over here at our resilience indicators, one of the most resilient in West Hawaii. It's a place that was covered by lava less than 200 years ago. So these resilience indicators include measures like coral cover that we've looked at, things like coral disease, herbivore biomass. These are the places where we expect that coral is going to have more ability to withstand the climate stressors that are coming for it. And so this is a really interesting report from 2019. And we can see that a lot of the reefs around the Kailua Kona area are in need of a little bit of help. Okay, so what does all of this mean? I don't know. I told you there was no heroes and no villains in this story. It really comes down to, what do we value? What do we care about? There are a million things in the world that we can focus our attention on. There's so much suffering. There are so many challenges. So why should we care about corals? Why this? Oh, sorry. I was going to ask y'all. What do you think? Anyone want to venture your reason why to care about corals? Yeah, Kater.
Marine biodiversity.
Okay, marine biodiversity.
Big fish, little fish, plants, we need it.
Oxygen production, CO2, sequestration.
Definitely plankton.
If we didn't have
doesn't
coral, we wouldn't have sand.
Okay, yeah, you
Right.
learned that.
Yeah.
If we didn't have coral, we wouldn't have sand. You heard about the efforts to mine sand from different areas of Oahu to feed the
Big time
beach at
Molokai.
Waikiki.
The oasis in the desert.
Yeah, any other reasons that we should care about corals?
Food production.
Food. Corals feed a lot of people. Yes, maybe up to 800 million people in the world are eating meals that came from a coral reef.
Prevents coastal erosion.
Coastal protection, yeah.
What kind of, coral themselves or?
The fish that live on the reef. So these fish that are adapted to live in a coral habitat that wouldn't be able to live in other places. Yeah, good question. Shoreline protection, every foot of coral growth can mitigate a meter of sea level rise, give or take. So as the ocean gets taller, if your reef is healthy, it's gonna match it. It's gonna grow, and it's gonna protect the shoreline and protect the islands. So those are all great reasons, and there's a few more I just want to throw out there. A canary in a coal mine is something we heard a lot during the bleaching event. This coral is sensitive enough that it can really show us what we're doing. We're creating these changes for the planet. We've been doing that for a long time. In fact, 20 years ago, I met a guy from Pohnpei who was coming to Hawaii to try to talk to our leaders to help us reduce our emissions so that sea level rise wouldn't inundate his taro fields on his island, was begging for help. But when the corals bleach, it's something we can all see. So we know that we're changing things. We know that this is a response of the coral. Our report card for humanity, I love this one. This came from a presentation I was giving not too long ago. How we treat our corals is how we treat our planet. Everyone has different belief systems. That's great. There's a verse in the Bible that says, "What you do to the least of these, you do to me." That's a verse that Jesus said in the Bible. But it's interesting to think about the least of these in the context of a coral reef. What is more humble than a polyp that is so small we almost can't see it? So it's important to think about these small things that are out of sight, out of mind for most of us most of the time. And this enrichment of the world, yes, masterpiece. I want to just spend a second on that, because how do we handle masterpieces in the human world?
Very delicate.
Care.
Right.
Very-
If you don't want to see the Mona Lisa, you're going to go through metal detectors, security. You're going to be in a climate-controlled building. It's going to be behind bulletproof glass. It's going to have security doors all around it. The restrooms there are going to treat the wastewater properly. We treat masterpieces with some reverence, and we think about everything that we do when we're in these places. Granted, maybe too many people are crowding the Mona Lisa, but she's much better protected than the places where we're crowding corals. And this is a masterpiece that not only is visually stunning, but protects our coastlines, provides food. It's doing so much more. It's growing in a way that we cannot hope to duplicate. And I'm all for artificial reefs, all for coral restoration, but the natural corals of the world are a masterpiece, and they deserve our protection. So we've talked about a lot of reasons that corals should be protected. This is another image where you see the reef coming down here. Beautiful coral reef imagery. And we hear a lot about protecting rainforests. We should, because rainforests are important biodiversity, oxygen. But half the oxygen comes from the ocean, so it's not shortchange the ocean, not necessarily specifically the reef, but we'll take credit for that too because of that ocean connection. Corals are providing about 70 times more revenue value per hectare than rainforests are. So when I say value, that can mean a lot of things. But in the United States, the estimated monetary value of coral reefs is about $1.8 billion per year. And that value comes from protecting the coastline from big waves, the mitigation of damage. It comes from tourism, livelihoods, the money that's generated from going to these special places that can inspire us all. It comes from the sale of fish and the value of fish that are caught on the reefs. So there's a huge human value of having these ecosystems. And scientists will call that ecosystem services. And ecosystem services is basically, what is this ecosystem doing for me? What have you done for me lately, coral reef? But $1.8 billion is seriously underestimating infinity, because there are cultures throughout the world that have developed around coral reefs that are intrinsically linked, where the coral is not a revenue source, the coral is a relative. Coral is a family member. The coral goes away, a lifestyle goes away, a way of life goes away, a culture goes away. And so cultural ecosystem services is the scientific term here. And this was a statement that was made during a workshop by one of my colleagues, or former colleagues, Manuel Mejia, who said, there's really no number you can put. You cannot put a number on the value, the depth of meaning and value that a reef represents. And so people are probably skeptical, like, I could put a number on it. But reality, once it's gone, it's gone. So what does that mean for us? Does anyone know this? See this word before, Liana? Those of us who are privileged to live here in Hawaii on this island surrounded by this coral reef, whether we were born here or we have moved here, we have assumed kuleana. And if the kuleana is not a familiar word to you, here's the definition. This is a Hawaiian term with many meanings. And some of these meanings are more than I thought when I first heard the word. I always knew kuleana was a responsibility, but it's also a right and a privilege. Our ability to live here is part of our kuleana. Our privilege of being able to live here is part of our kuleana. It's also a reason or a cause. Our kuleana can be our motivating cause, why we do something, a function and a justification. So this is a very important word, and one that we should all know if we live here in Hawaii, because it's now our kuleana to take care of this place, and it's not optional. So how can we do that? I can't tell you that. I can't tell you how you can fulfill your kuleana to take care of Hawaii, because I don't know what you're capable of. You can go out and count fish, go out and survey coral, create art, teach kids. But it has to tie back to the place that we live and to the care of nature that is incumbent upon us. And so if you want to talk more about that afterward, let's do it. One of the ways you can fulfill your kuleana is to volunteer and to work, to take care of this land, to heal this land, to take care of our ocean and to heal our ocean. It's just a picture of a family work day at Kiholo Bay, where we're restoring a Hawaiian fish pond in order to make more fish that will go out onto the reefs, take care of those reef areas, and help these families sustain generational traditions. Who would think that building a rock wall could be a kuleana that helps reefs, but that's why I said I can't tell you what the answer is. We could all drive electric vehicles. Where are your rare earth metals going to come from? We could all have fewer children. Where's the future of the earth, the planet? So there's no silver bullet here. There's no easy answer. I already told you it's going to be hard in the very beginning, and it will be. It's going to really require us to think carefully about every action that we take, and likely to sacrifice some things that we take for granted now if we want to have these magnificent coral ecosystems in the future. But we have to do it. We don't really have a choice. We can do it. We're capable of, I think, more socially than corals are. So a coral polyp can work together and create an island and stand up to the full force of the ocean and survive in water that it has no business living in. If a coral can do that, what can we not do? But we got to work together. We have to stop letting forces divide us that are preventing us from making progress that we need to make as a species. And it's our kuleana to do that. So with that, I want to thank the folks who are helping me be here today as the executive director of Huiʻaloha. These are some of our funders. And then I know Malamakai is a nonprofit and is looking for support. And if anybody is interested in learning more about and supporting our nonprofit, before November 1st, every donation that's made to Huiʻaloha, including our educational and stewardship programs that are connecting people to the land to take care of it, will be matched dollar for dollar. So there's an opportunity. You can scan this code with your phone. There's a couple sheets of paper floating around here if you'd like to scan the code. But with that, I want to say thank you to all of you for letting me ramble on for so long, and invite any questions that you may have.
Hey, Chad, can you talk about, have you seen an evolution with the ostensible managers, marine managers for the state, DAR, the whole play of people who have a role? How has that changed, if at all, in some period of time since you've been associated with them off and on?
That's a great question. So I've been, associated with DAR for 23 years, and what I've seen is the progression of science across that time has been really strong. And what I mean by that is that the managers have had a very strong scientific background, uninterrupted. Some of you may remember Dr. Bill Walsh, a fantastic scientist who set up the long-term monitoring along this coast. That's a legacy gift that continues today, and it's generating a lot of the data that we saw. And what I'm noticing with the younger generation is that they're much more attuned to the cultural significance, much more attuned. They have learned it from a very early age in many cases. If not, the culture of the agency is more receptive to that than it has been in the past, perhaps. And so what we're seeing now within the managers of these reefs is that they're looking at cultural values, at cultural justifications for protection, and cultural use of areas in a way that we weren't looking at 15 or 20 years ago.
You talked about resilience. Do you see evidence of corals becoming more resilient? I mean, are they adapting to these changing times? Should some of the coral restoration labs actually be producing hybrids that are more adaptive?
People are doing that. People are looking at the corals, Super Corals project, the Super Reefs project is out there, and they're trying to clone, because corals are clones, we know now, to clone the strongest and most resilient corals. And that's where a lot of the seeds come from for the corals that get outplanted onto reefs, and they should be doing that. But a note of caution. In Florida, the Florida Keys, where coral restoration has been underway much longer than it has in Hawaii, reefs were planted with very high heat tolerant corals. These most resilient corals to thermal stress at the high end of the range were planted on reefs. There was a cold snap, cold water came through, corals bleached and died, and it was not the success that folks were hoping it would be. Ultimately, have a lot of faith in nature, and we can and should maybe pick winners and losers. I also think that there's room for preemptive restoration. What I mean by that is we don't have healthy seabirds in Hawaii. Our shark populations are a fraction of what they were, but can we simulate that? Could we feed corals through a bleaching event or before a bleaching event to help them survive? There's a really smart student working on that right now at Hawaii Institute of Marine Biology to see if there's another way to do restoration by helping the corals survive the way they would have when these ecosystems were intact.
You think over time they would naturally adapt to warm waters?
Yeah, I mean, the ones that don't adapt will die. And so as long as there's room for them to settle and to grow, that's possible.
Thank you.
Are there any examples of where the coral is coming back in a highly populated area?
There are some. There are examples where the coral is coming back even in some harbor areas. I'm trying to think of a really specific example from Hawaii.
Outside of the breakwall at Kahului.
Yeah, how many people go in the water at Kahului every year?
Hardly anybody goes outside the Menominee Wall.
There's a ton of baby cauliflower coral out
Oh
there.
yeah, it's amazing.
And how's the water temperature out there?
pretty stable, because it's mixed a lot with that breakwater, the Menehune wall.
Yeah.
Seems like it's flushed really well, and there's a lot of groundwater coming out.
So you feel that cold water of the groundwater when you're swimming around. That's an area that's downstream of a lot of people. Whether that groundwater is touching the human influence or if it's coming from deeper underground or farther upslope would be a fun question to study. Kyle, what example? Right here in your backyard.
Outside the wall.
Yes.
So we talk about corals adapting, but given the model that we saw earlier on about the zooanthi being, well, actually the things that are dying, really isn't it the zooanthi that should adapt rather than the corals?
Yeah, I do think there's room for some adaptation of the zooxanthellae. Now, that's typically a dinoflagellate, which is basically a plant that can swim. And there is some evidence that there are clades of zooxanthellae that are more heat tolerant than others. And what you see in those cases is they may not live in every coral species. They may only live in a subset of species, maybe only one species. And so you'll see differences in the ability of individual species to tolerate these high temperatures. And some won't bleach, and some will. So that can happen. How quickly that can happen, we don't know. And the estimate is by 2055, there will be temperatures that would cause bleaching every year. Whether corals will bleach every year by then, if they can adapt fast, maybe not. But that's the estimate.
How quickly do the zooxanthellae actually settle a new coral polyp?
I mean, I've seen a single coral polyp with pigment. So,
Yeah.
I haven't studied it in a lab or anything like that, but it seems like as soon as the polyp is there,
It's
the
available
capability is
somewhere.
there for the zooxanthellae to come in.
I was told that, or I learned that some corals pack the egg with zooxanthellae from the mother. Some do not.
Okay, so they're sending that along with the clone.
It's in the egg. So they have zooxanthellae when they're fertilized, but
Okay.
other corals don't. At least I learned that a long time ago. Where do the zooxanthellae go, though?
The leading theory on that is down into the sediments, the sand, the interstices of the reef, but I think that's an area that needs more research.
Yeah, because when I was learning this, they said they never found it in a water sample.
Yeah, that's why I think it might go down.
So the crown of thorns is not only getting an animal, it's getting a plant, so it's
Well, it's getting an algae.
algae, yeah.
Yeah.
Well, and the coral polyp itself that it sucks out.
Yep, it's having a salad is its staple. All right. Well, I'm happy to stick around if anybody has any more questions, but I appreciate your attention and your time. Thank you.
Thank you.
Thank you.
But I'll share my contact.
Okay.